Okay guys, so we're going to be looking at equivalent sets or one-to-one correspondence, right? It's the same thing. And it says sometimes it may be necessary to ask whether or not two sets have the same number of elements. If the number of elements in the first set are the same as the number of elements in the second set, they are equivalent or one-to-one, okay? So this is an example here. A has 1, 2, 3, and 4 in it. And B has A, B, C, and D in it, right? And we can see here that number of elements in A is equal to 4. There are 4 elements, right? And the number of elements in B is also 4. There are 4 elements in B, right? So since the number of elements in A is equal to the number of elements in B, which is 4 each, A is equivalent to B, okay? And that's what that sign means. This sign means equivalent. Cool? Right, this sign means equivalent, okay? So if we say that A is equivalent to B, we have to put this symbol here. And it's basically like 2 arrows, right? Is equal to B. This means equivalent. Okay, guys? So it's pretty simple. Let's just do another example here. Let's say C is equal to A, B, C, and D is equal to 1, 2, 3. Because C and D have the same number of elements, C is equivalent to D. All right? C is equivalent to D. Okay, guys? All right, so let's move on now. We're going to move on to Venn diagrams now. We're going to look at Venn diagrams in total now. All right, guys? All right, guys. So we're going to be looking at Venn diagrams, and it says, in drawing a Venn diagram, we use a rectangle to represent the universal set and circles inside the rectangle to represent subsets, okay? So in this case, we see here we have a Venn diagram, and this entire rectangle here is the universal set, and we have a set A in that universal set, which is equal to 1, 2, and 3. All right, guys? Also, we can see here that the universal set is equal to 1, 2, 3, 4, and 5, okay? Because 4 and 5 are outside of A, but they're still in the universal set, okay? All right, so let's look at another definition, okay? We're gonna look at some definitions about how we can actually use these Venn diagrams to solve problems. All right, guys? So let's get into it. Cool? All right, guys. So let's look at this definition now. It says the complement, right? The complement of a set A prime, that's how you pronounce it, guys. A prime, which is the complement, is a set of all the elements in the universal set U that are not in set A, okay? So we'll have the rectangle here for the universal set, right? And we can see in the universal set that there's 9, 11, 12, 1, 3, and 7, right? And in set A here, we have 1, 3, and 7, right? But it says here that the complement A prime is all of the elements in the universal set U that are not in set A. So if you notice, we have everything outside of set A shaded here, and that shaded region represents a complement. So clearly A complement is equal to 9, 11, and 12, okay? Cool. All right, so just think of it, guys, as everything outside of A, okay? So A complement would be everything outside of A, all right? All right, let's just draw a little example here as well. Let's say we have a small Venn diagram here, and inside here we have B, and 1 is inside B, and 2 and 3 are outside B, right? B would be equal to 1, and B complement would be equal to 2 and 3. Cool? So it's the same thing. The shaded region here outside of A represents A complement. So A prime is equal to the region outside of A, everything that is not in A. All right, guys? It's pretty easy to understand. Take your time and just soak it in, right? And get used to it because you're going to use this really often, okay? Cool. So let's move on now, guys, to another definition. All right, guys. Awesome. So we're looking at this definition now, and it says the intersection of two sets. All right. So if A and B are two sets, then the intersection of A and B are the set of elements that are common to both A and B. Okay? Cool. So an example of how we write it here says A intersect B. This N, upside down N here, means intersect. Okay? It means intersection is equal to X such that X is an element of A and X is an element of B. Cool. So X has to be in A and it has to be in B. All right. So if we look at this Venn diagram here, we're looking at the universal set and A and B. We can see here that there's an overlapping period between A and B, and the numbers 3 and 4 are in that section, right? So this section here between A and B, the numbers are both in A and the numbers are both in B. That section represents A intersect B. Cool. And it would be equal to just 3 and 4 because 3 and 4 would be in A intersect B. All right. So it's pretty simple, guys. You just have to look for the numbers that are in A and are in B. Okay. So it's not rocket science, guys. It's really not too bad. All right. All right, so anytime you're looking at two sets, let's draw two circles here. The A intersect B section is the place right in the middle here. This period right here. That's the section that represents A intersect B. All right, guys. Cool. So not too bad. I think this is really easy, and we're gonna do some examples of this. But now we're going to just basically look at some general rules for the basic Venn diagram with A and B. Okay, so we're gonna look at some examples now. All right, guys. All right, guys. So that's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.